Detecting and responding to threats in the cloud is harder than doing it on-prem. Even when you do have the visibility you need, legacy security workflows weren't designed for the speed and complexity of cloud environments. Cloud-native security solutions from ExtraHop are purpose-built to spot threats across the hybrid attack surface, provide detailed investigation steps, and help you automate response. Request your 30-day free trial at securityweekly.com/ExtraHop. Welcome back, everyone, to Enterprise Security Weekly. Quick announcement, we're looking for high-quality guest suggestions for all of our podcasts, filling some upcoming slots. If you'd like to suggest someone for the show, go to securityweekly.com/guests, and we review those on a regular basis, so please do that. Matt Cawthorn is the VP of Sales Engineering and is responsible for all security implementation and leads a team of technical security engineers who work directly with customers and prospects. Matt, welcome.
Thank you. Great to be here.
Ted Driggs is here with us. Ted is the head of product at ExtraHop and is a seasoned customer-focused product manager with a background in enterprise IT. Ted, welcome.
Thank you. Great to be here.
And folks who want to learn more, make sure you go to securityweekly.com/ExtraHop, get a demo/trial, and check out all of the things that ExtraHop has to offer. Today, we're talking about why the cloud stall or hesitation to go to the cloud is now the cloud surge. I want to turn that over to Matt and or Ted to kind of talk about what you folks have been seeing, especially with your customers, in the movement to the cloud.
Sure. Ted, I'll kick it off and then feel free to add any color. One of the things, as someone who's out in the field and has been for many years now, we're seeing lots of access limitations into the data center given the current situation. So a lot of staff are stripped. A lot of them were remote. In fact, most all of them were remote, aside from a handful of essential staff, and we just can't get access into the environments that we see. And so we're seeing so not having access to the environment doesn't mean projects stall or they go away. So we're seeing an uptick in acceleration towards closing the gap, the enterprise adoption gap for cloud, for sure.
The other thing that we've noticed is a lot of companies had a notion of their perimeter that has been really punctured by the increase in use of VPNs and the exposure of a lot of these previously sensitive CorpNet-only resources out to people at home. It's not feasible to stop business entirely for the duration of COVID. And once they've crossed over and realized, okay, we do know how to make these things available outside of HQ, they're much more open to continuing with cloud and getting the benefits that cloud provides.
Yeah, go ahead, Matt.
I was going to say, one of the challenges I think a lot of organizations are struggling with right now is how do you monitor remote usage, right? Mm-hmm. If I can't have people on-prem, but the systems are on-prem, or if I haven't deployed capabilities in the cloud and now I've moved all that stuff over to cloud, what kind of visibility do I have into this entire remote workforce that I wasn't planning for, 6-8 weeks ago? So, Matt, I'm curious, kind of what are you seeing customers start to do to address some of that remote work case to really get some of that visibility back?
Oh, man. A very broad range of things that cover a full spectrum of sort of fire drill open access to having to scale VPN concentrators emergency style. Ted, I think you had a great quote. What was it? I'm going to butcher it. COVID is a change, is a global change freeze that doesn't care about.
Yeah, it was we're used to, with data centers, there are change windows, and now that we are all physically kept out of our data centers, we're in this change freeze that's not under our control. And that's forced a lot of teams to go back and rethink their deployment paradigms. Also, just on the subject of the VPNs, ExtraHop has been doing work with customers now to improve our VPN visibility so that we can better answer the question of, well, who is accessing all these resources now that I've thrown the doors open? And how do I keep attackers from taking advantage of these holes in the perimeter to come in and get stuff that they're not supposed to?
Right.
Just to be opportunistic for a minute, and to the extent that this isn't completely obvious, but we're seeing a lot of just open RDP systems that are now popping up in Showdown anew, and just please don't do that. for anyone who's listening, if just don't do that, please, because it's a known sort of vector, and there are other better ways to do it. I understand emergency situations call for emergency actions, but these things are lingering around, and because of our visibility, we just see them there, and we see access from places that you probably don't expect to be accessed from. So lock that down.
Now, are you also seeing a lot of capabilities move into the cloud platforms because it's actually easier to deploy some capabilities in the cloud now that I don't have access to the data center anymore?
Absolutely.
Yes and no. The no there is that this is not a particularly orderly experiment with the cloud migration or with work from home, right? It's important to remember that companies are under pandemic conditions. So employees have kids at home because school was canceled, and the level of anxiety has meant that we are seeing that rise, but it's not been the surge in the way that that the cloud providers initially hoped for.
Yeah, it's not a controlled surge, right, Ted? It's kind of like an emergency frantic surge.
Right. I suspect that there's a lot of well-architected review documents that are lying on people's floors now because the idea of stopping to architect the thing well has gone out the window in favor of we need something running now.
Yes.
And that I mean has such a high likelihood to lead to exposures, especially with a lack of visibility that may be present when you're deploying those new systems. I mean, a few years ago, we were into the same situation, right? Emergency situation, deploy something to the cloud, and like, oops, you make one small mistake in your VPC and in network policies in AWS, and you expose something to the internet that you didn't intend to, and bad things happen, right?
Yeah, I'm worried that a lot of companies are about to learn the shared responsibility model the hard way. They're about to find out exactly what security of the cloud does and does not cover, and then find out that their burdens for security in the cloud were higher than they had anticipated. So hopefully nothing too bad comes of that. But
yeah, and it feels like lift and shift in general. I think if done perfectly, it's a fine strategy, but done under duress, it's very, very fraught with peril because the paradigms in the cloud look similar on the surface, but the actual architecture and the implementation in the way things really should work are quite different. And under such an intense environment right now, I think lift and shift is a lower friction path on the surface, but to Ted's point, it probably does open us up in ways that we might not expect.
And the way that, historically that I've addressed these issues on premise, right? And if we were moving fast on premise, I think we could always kind of take solace in that we had some network visibility, right? We were tapping the network. We had tools and techniques and a process to look for anomalies and be able to flag things before the attackers were able to take advantage of them, or at least notice those things early on. My concerns with the cloud are when developers, operations, IT staff, sysadmins, what have you, are now deploying stuff to the cloud. You can very easily, unless you have the right architecture and tools, lose that visibility from the network, which gives us that source of truth. And that's what I like when we've done a webcast in the past. We're going to talk more about it today. That's what I like about the Extra Hops solutions, being able to integrate that, give us back that visibility and anomaly detection to say, well, wait, that in our case, right? Oops, we deployed that. It was exposed to the internet, and learn about that as early as possible and have that visibility.
Absolutely. And this is especially true. It's interesting. I come from a similar pedigree. I was on the sharp end of the stick in ops for years there. And first of all, it's a grueling existence, even outside of a pandemic. So my heart goes out to the SecOps and the IT ops teams out there, DevOps, because it's a disproportionately difficult task, in my opinion, largely because folks are missing that empirical evidence or the analytics to support any given decision from a technology, app delivery, security perspective and beyond. And you're exactly right. One of the sort of last mile coverage gaps in the cloud has been the sort of observational point of the network. It's been approximated by, say, VPC flow logs, but VPC flow logs are simply that. They're flow logs. They don't give you any sort of transactional information or broader context about the nature of the connection and the layer 7 transactions traversing it, say. And the enterprise folks like you who got used to having network visibility are really, really aware of this gap, and we're seeing quite a bit of uptake given the cloud provider's new functionality with traffic mirroring. So it's been very refreshing for us, and it's a wonderful opportunity to help customers get the visibility they expect.
Yeah.
Yeah, it's interesting. There's so many things that can change in your cloud configuration. One of those is logging, and when and how or if that's applied at any given time. So I've never, I've always liked to caution people about that particular aspect of logging, that it's really not under your control, right? People can turn it off, for example, or deploy something new without logging being enabled, or those logs are going somewhere where you're not collecting them in the central repository, right? I mean, that list can go on. But when it comes down to that network visibility, that's what I used to fill that gap, right? Was if it's going to traverse the network, I can see it, and that's awesome. If it's in a log, I don't know what I might be missing, what I might not be missing.
Yeah, and as soon as I land on a system as an adversary and escalate my privileges, I'm going to go after the processes that I don't like
Yep, logging.
a log forwarder or like potentially an endpoint solution. It's not that those solutions aren't good. SIM is awesome, endpoint is awesome. Everyone should use that, but they are, to your point, they're subject to externalities. Our CTO has this wonderful sentiment that the network has some fundamental properties that make it pretty unique. One, it's observational truth. It's as close to ground truth as you can get. Two, it's very, very difficult to evade. And three, it's almost, it is impossible to turn off, because then you've defeated yourself if you do. And so the network really is a crucial part of the strategy of this, the cyber triad, right? It's SIM, EDR, and NDR for network.
Mm.
There's another thing to think about there too, which is the structure of the data. Log data, you can spend a ton of time trying to clean it and get a consistent understanding of what you're seeing from different servers running different versions of an application or running different applications that have different logging paradigms. But innately, network traffic is a contract between two systems. So that means that when you're doing a semantic analysis of network traffic, you're starting from a much stronger place than if you're trying to do an analysis of log data.
Mm. And it's not just the visibility piece. Some of the things that I've observed in the Extra Hop product line, right, are absolutely the visibility piece, but also the ability to take actions and how the cloud enables us to do those things. And those of us that have tried to do it before with the network and network admission control solutions, right, you had a lot of mixed success, right? I think things have gotten better today, but it's still very difficult to implement that across a physical switching infrastructure. When we go to the cloud, we can take some I think much better actions based on observed events, and you folks have built that into the product, correct?
Yeah, Matt, are you demoing that?
Yeah, I can show you a demonstration of that functionality
Sweet.
today. We do have that capability built in, and to your point exactly, Paul. The cloud for us really is, at the end of the day, we do stream reassembly across network traffic that's mirrored to us, right? So we do network traffic analysis for security. And so we really don't discriminate which environment we run in. It could be ESXi, it could be the enterprise on a traditional wired network, or it could be up in, say, AWS. And one of the interesting things that, we've been sitting on this latent potential for, that's largely not totally gone unrealized, but in the context of the enterprise, it's very difficult to mash up workflows and get meaningful automation absent some third-party system that you have to sort of drop into the environment and configure. But the cloud has this capability just built into the fabric, the management plane of the cloud itself. And to the extent that you're API friendly, you can get some very, very interesting workflows enabled. And I'm happy to show that to you guys today for sure.
Sure, that'd be awesome.
Ted, any comments while we get this going?
I was going to say, please don't do what you did when you were developing this, which was to turn it loose on the rest of our machines. The those of us in R&D were wondering why our EC2 instances kept dying, and it turned out that Matt was running some tests, and he just figured, oh, I'll just start terminating instances, and yeah,
Well,
that was a real
the
fun
fine line between clever and stupid when you're doing the early stages of testing, I think, right?
We all know Matt's not the only one to ever make those types of mistakes. I mean, I've been guilty of that so many times, and all of us, I think, have. So.
Oh, we've all.
I couldn't tell if it was a mistake or if he was holding us hostage for a feature request. Honestly,
Could be that too.
So, guys, really quickly, I will. What I'm going to do is I'm going to show you. There's a specific. Let me go to. I assume you can see me, yeah? My screen?
Yes.
Yes.
We can see your screen.
All right, so I'm going to go to the system here. This is a particular system with 6 behavioral detections on it. And it starts with some lookup, some recon, and it ends with some data exfiltration. So just to dig into this, I want to give the viewers a little bit of context about what's going to happen here when we talk about these automated actions in the cloud. So for example, this particular detection, it's lateral movement, it's showing some suspicious file read activity. Based on some modeling that we've done, we haven't seen this system, we haven't observed it, given its past behaviors, we haven't seen it observing this way. And we see it related to, we relate this system to its early sort of recon stages, right? We see DNS lookup, some ping scanning, UDP. Then we see an attempt for SMB, like brute force to these shares, then reads. And we'll see the role of it as an offender or a victim as it sort of moves on this timeline. So the lateral movement stage, the sort of post-compromise lateral movement stage here is an absolute strength of ours. We really sort of emphasize that. That's where dwell time lives and the gnarliest problems in enterprise security. And then we lastly see it exfiltrating data. Now, without having to click around, all of this information is right here. And I've got investigative capability just embedded in the detection card itself here. So I can see the usernames involved and which files were touched just before this exfiltration event occurred. So for an analyst, they need not know how to navigate the system. They don't need any bespoke. They don't need to know a query language. It's just here sort of embedded in the user experience itself. And this is something that I'm going to hand this to Ted. This is something that Ted and his team have put a lot of effort into recently, and we're very happy with the results. And these things can then invoke actions in, say, AWS or one of the cloud providers that can then automate response, which I'll show here in a minute. Ted?
Yeah, can you scroll down a little further on this one, please, for me?
Sure, of course.
So we spent quite a lot of time on this, trying to really get down to making one-stop shop for people. And in the process of doing that, one of the things that we encountered was the need to have the underlying transactions available. So Matt, if you could scroll up a little bit and just go to one of the records things here, that should work, the magnifying glass on Investigate servers.
Okay.
There we go. So we, in addition to pulling a lot of this data into the detection card itself, we took a step back and said, all right, the analyst needs to have this information available so that they can get PCAP, so that they can get proof, and they can really go as deep as they need to understand exactly what data may have been compromised. One neat trick that we discovered back when ransomware was more prevalent of a problem was that using the data captured by the extra-op system, we could reconstruct files that had been encrypted using the packets that had been read by the ransomware pre-encryption. So the packets that underpin these give you that full visibility into every single fact that was potentially exfiltrated in this case. But coming back to the cloud discussion, the customers really have needed more and more lately, either for vendors to provide turnkey cloud scale solutions to deal with this data, or to have vendors plug into the big data bets like Splunk that they've made within their organizations. Nobody wants to run multiple Splunk farms if they can help it. And we've seen with Sentinel, Chronicle Backstory, the rise of these cloud SIMs, basically. Backstory less so than Sentinel, but sorry, I'm trying to figure out how to articulate this. This stuff right here is the gold that underpins any meaningful investigation. So in the 8.0 release, we added that inline visibility, but we've also added this under covers, the ability to plug into Splunk or to bring your own BigQuery or to have ExtraHop manage a cloud scale record store for you so that you don't need to be worrying about, hey, how am I going to scale my deployment as I go through this cloud surge? And I'm really excited about that. I'll be honest, Matt, I forgot which piece you had wanted me to talk about because
no, this is great.
Inline investigation to me is kind of the apex of giving answers in no clicks. And then that kind of led me down this path of making sure that all these records are available at a moment's notice for the analyst.
That's right. With effectively now sort of cloud scale look back characteristics down to the transaction detail, which is really, 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 really powerful because now we need not turn to sort of retroactive packet capture analysis, for example. We've got, it's deterministic. We know that this particular Excel spreadsheet was touched at this particular time from these two different hosts. And so it's a very, very, very powerful model. Excuse me. And with this alternate backend strategy now, you're not hemmed into using some proprietary ExtraHop stack. What we're doing is we're able to integrate with the things that you're likely to be using in the first place. So it's a feature that we're very excited about. And it's very sort of cloudy by nature because it's API friendly. We can export this telemetry out and stream it in real time to, say, BigQuery or something like that. And from there, the use cases just explode. It's a very powerful model.
So, Ted, you said something during the ransomware attack that you saw the file pre-encryption and then post-encryption. I mean, is that a restore point from a ransomware attack that you could pull the file back out and recover it because you saw it before it was actually encrypted?
We had customers who were able to do that successfully.
That's awesome. Is that because the attacker downloaded it before the ransomware attack?
Yeah, they do an SMB. Mm-hmm. They read the file down to wherever the ransomware is running, right? Mm-hmm. They encrypt it and then they write it back to the network share. So in order to have read the entire file to do the encryption, they have to download it, mm-hmm. and therefore it's available in
it traverses the network, right? Yeah, that's awesome.
That's right.
That's a very interesting use case. That's why I heard it, and that's why I wanted to focus back on it. It's a very interesting use case for recovering from a ransomware attack because the file you saw hit the network before it was encrypted. There's your restore point.
That's right. Yeah. Just from an audit trail perspective or a sequence of events perspective, deterministically when each file was accessed from the victim. So you've got this just wonderful, microsecond granularity on the timeline of events here with the transaction logging.
Well, this comes back to Matt's comment about the ability to automate response to cloud things. If ransomware got into an EC2 instance of yours, you can fully automate that process of, okay, ExtraHop saw ransomware from this offender, stop that offender from doing anything else, run the packet queries needed to go grab all PCAPs that were coming in or exiting from that particular instance. And now you know that you've snapshotted for later whatever is needed to rebuild any files that were touched before you quarantine that system.
That's awesome.
All right. So that's a good segue. You want it? So what I'm going to do is I'm going to close there we go. This is the right, wasn't sure if this is the right image. So we're going to walk through an automation workflow using what we've just seen as a backdrop. So we've got an event of interest. Here it could be any of our detection types. I've got a trivial detection that's looking for, it's going to do a TI lookup, and this is a rules-based detection. Most of our detections are very heavily machine learning driven, but we do believe philosophically that our customers should be able to use rule-based detections for things that matter to them instead of just listening to the vendor, right? It's sort of your security strategy your way. And so we've got a rule written here that's going to look, here's our system. It's going to fire the detection up into Amazon SNS natively, just right from is we're going to emit our detection event into SNS, and it will then publish it.
I'm sorry, Matt. What's SNS?
Oh, I'm sorry. Yes. So thank you. Simple notification service in Amazon. It's a native service that is very awesome. And what it does is it's a fan out. I push one message into this message bus. It's an enterprise IT message bus. I push one message in, and it can deliver that message, that same thing, to a mobile phone via text, email, or programmatically it can go make its way into Kafka or big data lakes or whatever. Here we're wiring it up to Amazon Lambda, so AWS Lambda service, which is as you know, it's serverless code. And so here, or code as a service. And so Lambda will consume this message, and it will take action based on a policy that we've set up in Amazon. And here what we're doing is we're very tightly integrating the messaging semantics, the messaging capabilities of our system with the management plane of Amazon itself. And so when this event occurs, we're going to publish this up into a message bus. Simply put, that message bus is going to send this into something that's going to run code. It's going to reach into the management plane and quarantine the system in question. All right. Any questions before? The preamble is important because the demo, I'm just going to give you guys fair warning. It happens so fast because this management plane in Amazon, it's effectively real time. So it's almost anticlimactic, really. It just kind of goes. All right. So here I'm going to hit this. So what's happening here is from this terminal, I'm actually calling up into the API, and I'm looking at a specific ENI. I'm looking at a specific host here. And I've got two security groups. One is in the DMZ and another one is in this Oasis subnet. All right. So when I run my malicious command, you're going to see this all is going to happen behind the scenes. And this, I think that's exactly the point for automation. You're going to see that action is taken very, very quickly. This is refreshing every second or so. So what's going to happen is I'm SSH'd into the system itself that's been presumably compromised. Let me make sure I'm SSH'd, actually. Sorry. Let me do a hard reset. It's the law of demos. And so what's going to happen is we're going to fire the detection over here. Okay. We have none right now. That's a good thing. We don't want to see any detections. This is the extra hop system. All right. Let me get logged back into this guy. All right. Now I'm going to run this command. This is it. I'm just going to make a simple wget. It's a client outbound call. And what's going to happen, this is a known sort of suspicious IP address, and it's got a bogus cert. We call them baby certs. It's very common in malware. They're going to Let's Encrypt or whatever, and they're getting these ephemeral certificates. And if certain criteria are met, we just simply don't trust them for this particular policy. So if I hit this, watch what happens. I'm going to hit it. I've got a 404 not found, but just that access alone, I'm going to go to the other window, and I can see within a refresh, here it is. So what I've done is I've sent this dynamically based on that detection firing. I've sent it into a null routed security group in AWS, basically. It can't do anything. And I've kicked off an image event to generate a forensic image of that system while it's running. So volatile memory is intact. And so if I'm a forensic analyst, I can get at all of the potential indicators of compromise that I want. But I also have the assurance that this system is effectively offline. It's absolutely offline, actually. And over here, I'll refresh and we'll see there should be a detection card here in a second. There it is. And so this event, a suspect SSL peer, this event was emitted into the management plane of AWS, which took an automated action based on a policy that we set based on sort of arbitrarily easy or complex criteria that we define.
It's in these times, it's a horrible analogy, but essentially you've quarantined the resource based on an action.
I have. So here's the console, by the way. Here is the actual image that's so we spawned a new AMI. So we've got the forensic image, but yes, it's been totally quarantined, and we've actually got a snapshot of that guy running for analysis. Yeah, it's very useful.
That's awesome. I mean, you've automated so much that it is manual effort, right? In just one action so quickly, being able to put that in a different security group and also have a forensic image and have that running all the time it's fantastic. I mean, it certainly lends itself to the speed at which we want to move in the cloud, and brings security to also that same level of speed and efficiency.
That's right. If you think about this, just DevOps as a movement, DevOps drove a lot of this sort of agility mindset for enterprise cloud environments, and security hasn't been able to keep up with that quite yet. I think that this type of functionality really changes the game if people decide to take advantage of it.
Yeah, and I think it required us to really think about security within the cloud platform itself, not as an external thing, right, Matt?
Agreed.
So now what we have is we actually have you guys embedded into that cloud traffic. You're actually inside the cloud versus trying to do this from outside, which I think has always been the challenge in these environments.
Super true.
One thing that Matt didn't show there, but is also really compelling with the native traffic mirroring that the cloud providers offer now, is you can fully automate the creation of those tabs, right? You can have, as a security team, you can say, okay, I want these subnets tapped, and then script out so that anything that comes online in those subnets is immediately sending its traffic for analysis. That addresses another one of the problems that we'd seen previously was, you don't need to have logging enabled on a system by system basis. You can externally attach this monitoring capability and know that you're going to get a consistent and complete view of that system, of that device's activity.
And
you didn't need somebody to go into the data center and build you a tap capability to tap into also.
Right.
One small correction on what Ted said. We don't need to. No one needs to script because we've got the CloudFormation template, which is really nice and speaks to the portability of the cloud. Right, we've got these template capabilities and this automation capability, and so now our users are just dropping the CloudFormation template into their environment, their VPC, and the tagging and the mirroring happens automatically. It's really, really powerful.
No, that's really awesome. Also, a non-security application could be for billing as well, right? If I walk in one day and I see a bunch of alerts that someone just spun up a dozen or 100 different instances, that could be problematic from a billing perspective.
Absolutely, yeah.
Yeah. It's funny, we were doing some math at one point about if you were to send traffic into one of ExtraHop's largest sensors from the cloud, I think we figured out that it would cost you about $11 a second to fully exercise the largest sensor that we can make, just in bandwidth ingress costs to AWS.
Yep. It's definitely a thing. Well, that's awesome. I love it. And folks that want to learn more, of course, can go to securityweekly.com/extrahop. I think this is fantastic technology and really helps security keep up to speed with cloud native applications. And deploying stuff to the cloud. So, Matt and Ted, thank you so much for appearing on Enterprise Security Weekly.
Great to see you again. Take care.
And with that, we will transition to our next interview with Justin Buchanan from Rapid7. Stay tuned.